The isolation level actually set by the TSQL is the context via which we can see the transaction being executed. It's a scenario via which we secure the transactions themselves. We guarantee the information being transmitted or being retrieved using the queries over the transactions. So the role of these let's say isolation levels is to secure to guarantee the information assurance, digital security or perps or information assurance perps on top of the use of the TSQL transactions. There are levels, yeah, we know, and those levels they guarantee that no interceptions. They guarantee that transaction would be fulfilled completely to serve the purpose of the project or the task or the yes, the flow. And before the isolation levels, we presented the here. Let's talk about the small recap on the asset properties, which they have to be actually adopted by all transactions without failure. And if any transaction has missed any of the isolation levels, sorry, any of the properties, those four asset properties, the transaction still might work, but it does not guarantee neither the digital security, is it secured, nor the information assurance, does it guarantee that the data will be actually carried out correctly without any modification or alteration. Is it intact? No, there will be no guarantee. A transaction might have one or more actually queries. This is for sure. As per an atomic view, which is the A from the asset, a transaction has to be seen unique, one task, whether it is held in one query or more. Because remember, we deal with databases, so only queries are in question. Only queries. Here in this example, here in this atomic transaction here, we have two queries, insert and insert. So we have two queries to execute. The first insert and another the second insert. They are both either to be executed in the same procedure or no. Both they would be actually cancelled. Either both or no. The transaction is atomic, yes, means it cannot be failed to execute only one. Either one or to roll back both. Sorry, either two or to cancel both of them. Cannot execute only one. No, it's not the point. So here we are seeing an atomic transaction. And the example is taking only two queries. It might have actually 100 queries, might have 10 queries, might have 5 queries, might have 55 queries. There is no limit. As many as the queries are there, since they are in the same procedure, same block, they are all to be seen as atomic process, atomic transaction, not to be seen actually as queries standalone, one by one. No, it won't be successful. So the atomic transaction has to be seen as one process by the system, whatever the content is. Yeah, and later on, actually, this atomic process, the creation of the this process, and later on, it would be actually called for execution only anytime required, anytime to call, it would be executed. Okay, continue. The second property actually we saw it was the consistency, and we said that a transaction has to be fully executed or fully cancelled, either fully reach the end and admit or fully cancelled. Yeah, because if it did not reach the end and admit what has been finished, this is not consistency. As per the example of the ATM, if the user withdraws money and here stops the system did not do the update and what comes after. The user will get the money and the bank will not be updated the account. The bank account will not be getting updated. Thus, there will be a money loss. This is not acceptable. So either to fully make them get executed or to fully cancel them. Here, when the user retrieves the money, the system has to find a way how to make the updates whenever the current electricity comes back or whenever the system is fixed. The update has to happen. Thus, we talk about consistency. The transaction is consistent. The third, actually, here, the third property from the asset property is the isolation, which is here to be seen when we talk about many queries to many transactions to be executed at the same time from within the environment. Those transactions they do not have the right to interfere each other. They do not have the right to intercept each other and stop each other to continue. No, if it happens, if it is the case, we are talking about a non-secure work environment and then after non-isolated transactions. So here the transactions they must be isolated in the sense of they are not isolated from the environment, no, but they are isolated from being recepted or interfered by other transactions from within the same program. Isolation. Last we talk about isolated transaction. Okay, three properties now. The fourth property is to guarantee those three. The fourth, which is the durability, is to guarantee those three. What does it mean? The atomicity, being atomic, or the fact of being consistent, or to be isolated. Those are aspects that they have to be actually respected by the system for all sessions. It has to be respected by the system for all sessions. If it's not the case, and this is actually what we call it durability. What does it mean? Means if a user number one, normal user, comes to the ATM machine, we take the same example, and he draws money. So the same process happens, identification, authentication, request the amount, receives the amount, and leaves the ATM. The same thing happens to another user, another culture, another different age, and so on. The same process to happen. Atomicity for all transactions, consistency for all the steps, and isolated. The transaction itself has to be isolated. So nothing to be specific. This is for all users here. Means here we are not talking about by name, user by name, but we're talking about sessions because there might be system users. So we talk about the sessions. The sessions, they have to be actually legitimate to have transactions with the same properties, all of them. Yeah, this is exactly what we were discussing. Here, every each single transaction, remember, we are talking about transactions. Every each single transaction has to be conform to these asset properties. It's a must. It's not a matter of we cannot. It's an order from the whatever. All transactions, they have to be conform to the asset properties. Remember that if a transaction is not conform to the asset, might still work? The answer is yes, true. A transaction means the process to happen from the front end to the back end or the vice versa. And generally, we talk about a query to be submitted or request to be submitted. So we talk about a process to pay. So here, the transaction itself in question, whatever the transaction content is, there have to be actually a commitment way in the sense of this transaction will it be actually utilized for official yes activity, or just remembering. Thus here we talk about transaction modes. We take the example of the earlier transaction. It has two queries. At the end, whether the system will admit that and the transaction will be considered and the modification will be saved. Otherwise, no, it will be cancelled. Even the queries that have been executed, that will be cancelled. There will be a rollback. There are four modes. There are four transaction modes. Here we can see them. Just let's discuss them briefly here. The first one, which is the auto commit transaction, and here we see a transaction with one standalone statement. Means it has only one insert or one select or one something like that. So in here we talk about an auto commit because the one based transaction, the one query, would be actually passed over a transaction that has an auto commit transaction mode. It has an auto commit transaction mode. The second category, which is the explicit transaction, explicit and implicit. For the case of the explicit, there has to be actually a manual indication that the transaction has been terminated, either to commit or to roll back. In this sense, okay, the transaction has 10 and 10 queries, and here we terminate. There has to be a word to say committed or roll back. This is actually the technical word. And in here, the transaction, the full statement here, the transaction would be the committed or rollback depends on the option given. Okay, for the concern of the implicit transactions, now we are talking about the same thing. We have a beginning, we have an end of transaction. Then after we have an an indication of, let's say, a completion, either the commit or the rollback. But implicitly, we have to start in prior. We have to implicitly indicate the beginning of the transaction, because in explicit transaction, there might be a startup after a process. Means there might be a nested transaction, something like that. Here, in the implicit, there have to be a must to indicate the beginning of the transaction. So here, implicitly indicated the beginning and the end of the transaction. But in terms of transaction mode, we are talking about the same thing. Manually, we indicate the rollback, and manually we indicate the commit. For the batch scope, the last transaction mode, the fourth, the batch scope transaction is a scenario via which we define a new terminology, new technology that helps us to become a batch scope transaction, where we can see that the batch scope transactions are not committed or rolled back when a batch completes automatically. But if there is no indication, automatically the transaction will be rolled back by default. If there is no, for this concept, for this category only, if there were no manual commitment, or let's say rolling back, it would be actually committed. When we talk about the batch scope transactions, we define a new technology via which we can see a specific type of behavior that .NET is following, which is the mass transaction, the multiple active result sets. The multiple active result sets is a scenario via which we can see nested transactions, and not only nested transactions. It's a scenario via which we can see a commitment and a rollback more than one time in just one program. MARS, MARS, multiple active result sets. Remember that. Yeah, exactly what we were talking. Yet, there is a technology that the TSQL actually enhances, which is when we have actually a long transaction and there is a chance of making errors or modifications, or let's say alteration from within the transaction body. Actually, developers might generate a save point to roll back whenever needed during the program. Those save points, they would be utilized to roll back. Okay, those save points, they are to be utilized to roll back, for example. When we talk about the mass transactions, we cannot set save points. We cannot use save points in this regard. There are reasons behind, actually, mainly because of the nature of the body. Yeah, so there will be no admission. There is no commitment, no rollback, nothing. Let's take the example of the following transaction, which is a non-mass transaction, non-multiple active result set based transaction. It's a transaction that begins here and it ends somewhere, but in here we have a create T1 ID. Here we create a table, an entity. We are inserting some values, and then after we are generating a save point. The one in red here is just user defined, but the keyword is that save space run, save run. Then after we're creating a point here, it's usually file name, save point one. We continue. Yes, then after we insert some records, and we roll back to that save point. There is a rollback to that save point, and then after we insert do other queries, then we commit all. Then we commit all. These are non-result set, actually non-Mars, actually multiple active results, so because we can generate easily the save point, and you can refer that. Okay. For the concern of the mass transactions, now the difference. We were discussing the non-mass transaction. Now, for the concern of the mass transaction, there is a slight difference, and you have to note that. Here in this example, here we are just defining a group of variables and entities, which are going to be utilized to a given server, whatever. So here we have an actually chance to connect to a server, and here it is. And then after we're passing some commands, here they are select, select, select. Okay. Okay, the first command we are generating cmd2 here, second, not the first. It is having an update query. It is having an update query that we are going to execute later. This update will be actually getting connected, or let's say getting executed based on a connection, which is this con, which is at the end of the day this server. Command one is a SQL command on the same con, and it has the following. Okay, command two, yes, the same connection, yet, sorry, same connection, yet different query, update. Now, the connection will be started. Always it was before, or it was only selection. The connection now it's opening, and it's getting opened. Then after the transaction is being called, which is the transaction we are creating now, and then after the command number one transaction or content is going to be referred to the transaction, or used to populate the transaction tran, which we just created now. The same way for the cmd2 command 2. And both of them now, just after being pointing the transaction, now both of them, they are going to be executed. So here, still we are doing some task on cmd1. Later on, we are going to make the, yes, here it is, the execution of both cmd1 and cmd2. Both of them, they are being executed. Commitment, rollback, one of the options that it has to be mentioned. And here we talk about the mode, the transaction mode, the commitment or the rollback. Here, the commitment or the rollback has to be clearly manifested. To commit the transaction tran or to roll back the transaction tran will not help us to commit the CMD1 or specifically the CMD2. Either we admit the tran or we roll back the tran. The CMD1 belongs to the trun, CMD2 belongs to the trun also. Thus, we are admitting both or canceling both. This is a mass transaction. Multiple active result sets. We have two transactions, and we can add third, fourth, and transaction. Yes, queries or transactions might be. That has to be either all admitted or just one admitted. So here we see the Mars transaction in question. Actually, this program here starts with try block. It starts with a try means there is an exception handling. So it starts with a try, and everything is in between those two curly braces. This one and this one here. Thus, if any exception happens during the runtime, this block here would be executed. The catch. Which is just something to be executed once an exception happens. It's an catch block. Exception handling process. The isolation, we were talking about transaction modes. We were talking about the transaction modes, the rollback or the commitment and form modes. Okay, let's move to the isolation levels. Isolation levels. Just to make you understand what does mean an isolation level, is a scenario via which we can see a long transaction being put in line, just waiting to see the adequate, if a request she received from a girl, is it exactly fitting her needs or not? Isolation levels, as per the example we took at the beginning, a transaction has to be finished before being intercepted, or to allow the interception, it depends. So here, both are actually transaction levels, let's say, that we can admit, yet one is accepted is accepting the interception to let the transaction be intercepted, other will not. So it depends on the need of the project in question. I'll take the attendance right now and I'll give you the recording. If you have any questions, you can ask, please.